Okay, welcome to Accelerated Math Factoring Quadratics with Real Roots. Okay, this one is got multi-steps in it, so tell your little sister to be quiet or whoever's making a noise in the background. You've got to concentrate. It's not super difficult, it just has multiple steps, and sometimes that just requires a little extra concentration. All right, now if you go back to solving equations that you learned a long time ago, starting maybe 6th, 7th grade, and you had a problem like 5x plus 7 equals 17, how would you solve that? You would start trying to isolate x, get x by itself by doing opposite operations. For example, here you would minus 7 from both sides first, then you'd have 5x equals 10. And most of you would know that x is 2 at this point, but you would divide by 5. That's the opposite of this. Divide by 5, you've got x equals 2. So simple enough. Now, the problem with this is that we have both x squareds and x's in it, and it gets real complicated, and this traditional solve by isolating x thing doesn't work so well. See what happens when you do this? If you try to isolate x, most people would say, well, let's do plus 6 to both sides, and we'd have this, and then they would get a little stumped at this point, and they would say, well, I don't know, maybe I should divide this by 2, and they would divide this side by 2. That's not really, you'd have to actually divide this part by 2 also, but here's my point, is it gets really complicated and you don't seem to be able to get x by itself. Some people would say, well, let's, most people would get stuck here at this point, and it just doesn't seem like there's anything you can do. So this traditional approach of isolating x doesn't work when you have x squareds and x's in the same equation. So we're going to take a different approach. We're going to first, well, I'm going to put the steps out here. First thing is we're going to look for a GCF. Is there a greatest common factor? And there is no greatest common factor here. So the second step we're going to do is we're going to factor this. And I just said GCF. No, well, factor. So what do you mean by factoring? It's working backwards from FOIL. And we're going to use this diamond approach that I think most teachers here at Northside have. And there's a lot of different ways to factor it. But the way that we've approached it is we put our A, B, and C variables designations under here. B is actually 1 in this case, and C is negative 6. And then we're going to use this thing where we've got the basement and the ceiling, and we found out that we have to multiply A by that C value whenever A is not 1. And then over here we've got this divided by AX divided by AX. Now you might be going, yeah, I remember something about that, but I can't remember how to do that whole process. So take a look at it. We've got AC on top, so negative 12. I got that by multiplying negative 2 times negative 6. I got AC up there. I got the basement. Right? It's going to get messy. All right? Then we're going to divide by AX, and that's 2x. Divide by 2x on both of those. And this is only because the a value is not a 1. If it wasn't, then we could use that straight diamond without this ax mess. Okay, so what goes here and here? Well, these things are two things that multiply to give negative 12, but they have to add to positive 1. All right? And I can list them out, 1 and 12, 2 and 6, 3 and 4, and I believe those are the only factors of 12. And then, of course, because it's negative, I've got to have some positive-negative combo. So I'm really looking for two things that where the difference of the numbers is 1, and it's 3 and 4. So it's 3 and 4, but one of them's got to be negative to make it come out to negative 12, and that would have to be negative 3 because when you add negative 3 and positive 4, you're going to get 1. So that works. Okay, now I want to clean that up just a second. And what we did was we had negative 12, 1. We ended up with, we were dividing by 2x, dividing by 2x, and we had negative 3 and 4. Here's the next step. Can you reduce these things? Can you reduce? In this particular case, no. Therefore, you're going to have this side of the, or this binomial, and your factored expression is going to be 2x minus 3. Over here, yes, you can reduce it, and it goes down to 2 over 1x. Can I reduce that further? No. Therefore, you're going to have 1x plus 2. Do you see where I'm getting that? Here's my 1x, and then plus the 2 up here. Over here on this side, I had the 2x minus 3. And that's just a little trick. That's not some super mathematical thing. That's just a little trick that somebody figured out, and it works. And this is all equal to 0. And that's a critical component to this. Now that we have it factored, so we did the GCF, then we factored it using the diamond. And now we're going to split it and solve it. And I'll show you what I mean by split it and solve it. We're going to split it into two equations, because if you have two things that multiply to give 0, then either one of these things has to be 0 or the other has to be 0. Any two things that multiply to give 0, one of them has to be 0. So either 2x minus 3 is equal to 0, or 1x, I'm leaving out the 1, x plus 2 equals 0. And then you simply, that was the splitting. Now we're going to solve. So we got plus 3, oops, and divided by 2. X equals 3 halves. That's one of our answers. Minus 2, or x equals negative 2. Those are our two answers, negative 2 and positive 3 halves. Whew, told you it was quite a process. So if you can maybe write this down and kind of get familiar with those, then you're going to do a lot better on these. All right, let's take a look at another one. Now I want you to notice right off the bat what is different about this one is it's not equal to 0. So when I said GCF first, really the first thing is set to 0. And what I mean by that is get it equal to 0, because without that setting it equal to 0, we don't have the power to use that whole little zero product property thing that we used just a minute ago at the end to split it and solve it. So set to 0. GCF, factor, split, and solve. So I don't know if you want to make a nice little acronym, SGFSS process. Sounds complicated. All right. So here we're going to set this equal to 0. So the first thing we need to do is add 15 to both sides. Whoops, I missed my X there. Add 15. You might be saying, well, where do I add it? Well, here's the deal. It's not a like term with anything else up there, so you just got to tack it on the end. But you got it equal to 0, so we set it equal to 0. Now we're looking for a GCF. Is there anything that goes into 6 and 19 and 15? No, 19 kind of throws things out because I believe that's a prime number. So we've checked to see that there's no GCF. Now we're going to factor it. We're going to assign our ABC values. We're going to do this little deal. We're going to put A times C up here. Ooh, 6 times 15, that's 60 plus 30, that's 90. And then the 19 is the basement. That's going to go down there. And right away I'm thinking like, oh man, I don't know my multiples of 90 that add to 19. But wait a minute, 90, first thing that comes to mind for me is 9 times 10. You may think of some other numbers, but 9 times 10, and that does add to 19. So we're, in good shape here. All right, and we're going to divide by AX, and that was 6x. 6x. Now, I just said 9 times 10 gives us 90, and it does add to 19, so we're in business. Now, we're going to reduce. We're still in this factoring stage here. We're going to reduce this, yes. 3 goes into that twice, and 3 goes into that 3 times, so we have 3 over 2x. Can't reduce any further. Can we reduce this? Yes, 2 goes into both of those. 2 goes in that 3 times. 2 goes in that 5 times. So we've got 5 over 3x. Can't reduce those any further, so now we can write our binomial expression on this side and our binomial expression on this side, and that's all equal to 0. Now we are going to split these and solve them. So 2x plus 3 equals 0, or 3x plus 5 equals 0. Minus 3 to both sides. 2x equals negative 3. Divide by 2. I think I'm still in my window here. X equals negative 3 halves, or minus 5 and minus 5. So 3x, whoops, equals negative 5, and dividing by 3, so x equals negative 5 thirds. Now there is one thing I want you to notice about this, is that some people have taught, hey, at this stage right here, you really don't need to create those little binomials and do all that splitting and solving stuff. If you look at this and compare it to the answer that we got, it was just the opposite of that fraction. 3/2, negative 3/2. 5/3, negative 5/3. So you can, do a shortcut and go straight there. I want you to see that it's equal to 0 and that you split and solve. But if you are comfortable with that and you want to go straight to this, take the opposites. You got negative 3/2 and negative 5/3. There it is, B. Alright, this is one where you go run to the teacher and go, whoa, but watch. It's not that crazy. At first it's like, whoa, I don't want to deal with fractions. All we're going to do is we're going to do this thing called fraction busters. Bust out the fractions. If you look at the denominators here, the common denominator would be 4. What I'm going to do is I'm going to multiply this whole expression by 4, each thing by 4, and watch what happens to my fractions when I do that. 4 goes into 4 one time, so that reduces. I've got x squared. 2 goes into this once, and 2 goes into that twice. I've got minus 2x. Did you see where I got that? I got the minus from over here, and I got the 2 from over here, and the denominator's going away. Here again, 4s are canceling each other out or reducing to 1, and it's equal to 3. So x squared minus 2x equals 3. If you had that one, you wouldn't run to the teacher. So if you can just knock out those fractions, and if you're uncomfortable with that, go ask a teacher and have them simplify that by getting rid of those fractions. All right. Now we said we had to set 0. We got to make it equal to 0. We're going to check for a GCF. We've got to factor it, and then we're going to split and solve. Or if you were comfortable, we could bypass these two stages and kind of take opposites of these that factoring step. Okay, so let's set it 0. X squared minus 2x minus 3 equals 0. And then I'm going to identify my A, B, C values. I got A times C up here. I got the basement down there. Notice that the A value is a 1. You might say, well, there was no 1 there, but that's an understood 1. Because of that, I don't have to do that crazy divide by AX thing. All I have to do is look for factors of negative 3 that add to negative 2. There's only two factors of 3. It's 3 and 1. One of them has to be negative. It's this one. Okay? Does that add up to negative 2? Yes. Now we're going to, that final step, we're going to take the opposites of those. As you can imagine, some people might forget that. We're going to take the opposites of that. So it's 3 and negative 1. If you forgot to take the opposites of that, you're jumping over here to B. That's not the answer. And yeah, they provide that negative or that opposite one. Try to fool a few people. Okay, and if you plug those back in, I really don't want to, but if you plugged them back into the original equation, it would make it true. All right, have fun with it.